Nye the Science Guy.
Kinematics. The study of the motion of points and objects without really considering the causes of said motion. Kinematics can be used to explain many real-life situations, such as walking to a grocery store or seeing a car zoom by. And a good understanding of kinematics serves as a foundation for the rest of physics. Now, some of you may be unfamiliar with this field and confused about the concepts and lingo used. For example, what is acceleration? And what in the world is the difference between speed and velocity? Well, let's break down the basics of kinematics and their mathematical usage. Let's say that this vehicle here is a car, because, well, that's what it is. Anyways, we can use this car to showcase the principles of motion and its many variables. Oh, and don't worry, I'm licensed. As I just mentioned, this scenario we just went through demonstrates the many variables of kinematics. For one, the starting point of our car can be referred to as the initial position of the object, or x naught. Similarly, the point where a car ended up is called the final position of our object, or in some cases just x. The time it took to travel this distance is denoted as the variable t. In terms of speed, the rate of change of the car's position is the car's speed. The main difference between speed and velocity is that velocity incorporates direction. For example, if we considered moving away from the house as positive direction, then our car had positive velocity. Similarly, if we start driving towards the house, then the car would have a negative velocity. However, speed would be positive no matter what direction we went. Since our car was at rest when we started, we would say that our car's initial velocity, or v0, was 0. The car's final velocity is, well, its final velocity, or v subscript x. Oh, finally, the car's acceleration refers to the rate of change of velocity, or how velocity increases or decreases in a set amount of time. In our level of kinematics, we only deal with a constant acceleration, so the acceleration is referred to as the term a subscript x. Now, all these variables I've just defined come together into what we call the kinematic equations. You may be wondering, what are these equations and why in the world do they work? Well, please consider the following. Starting with equation 1. If we define acceleration as the rate of change of velocity over time, then we can simply rearrange the variables to get the first equation. For equation 2, we can define average velocity in two ways. One in terms of position and another in terms of velocity itself. If we set both of these equal to each other, while substituting vx0 plus at for vx, which is found in the first equation, then we can simply rearrange the variables and solve for x, which gives us this final equation. An interesting thing to note is that this final equation here does not incorporate vx, so it's a very useful tool to use whenever final velocity is not given or can't be found. Lastly, for equation 3, we start by solving for t in equation 1. Then, we take this expression and substitute it into the average velocity relationship. Through rearranging, we arrive at the final equation. Now, this equation is especially useful since it doesn't involve t. So, if time is ever a mystery in a certain problem, this equation is a great tool to use. Well, that's it for today. I hope this lesson gave you a clear understanding of kinematics and accelerated your learning of physics. Thank you for your time, and God bless you. Samuel the Physics Guy, out.